before we go on, I do want to give a final example of what a constant time algorithm is, right? Maybe we're thinking, oh, so if there's what takes one step for each item, it should be O of 1. No, we're looking at the overall time, how many steps it took for all n items, right? So what does constant step mean? O of 1. Well, constant time means it does not matter how many items you're dealing with, it's always going to remain the same, right? So let's go ahead and just take a look at that. Let's go ahead and do one. Public static void int how big, which takes in a list of stuff, right? Oh, I'd have to make it a generic method, list of list. Although, if I want to say it's going to just take in a list of anything, and I don't want to put in that, and I'm not going to use the type E anywhere, I could just simply do this. Yeah, ain't that weird? That's just a wildcard marker. It says it's a list of anything. Okay, but I'm not going to use that the E, since I'm not going to use the E anywhere, but I want it to be a list of generics, I can do that. So, cool thing there. We're going to learn a bit more about generics in this example. It's not something I'm going to ever really use on a test, but it does exist. So return. So how big will return how big the list is. So that will return list.size. Now let's go ahead and see what that looks like. Right? In the interface, it's just that in size. But if we look at our algorithm, it just simply returns a variable, right? So let's go ahead and time this, right? Right, so I'm going to move the creation of the list outside of this, outside of our timing method. And the reason for that is, actually, I'm going to move, the creation of our, I should just really do this the way, the far-fetched way I was doing it earlier. We're going to move the creation of the list outside of the timing, because what I want to time right now is not how long, it's just how long it takes to call this, how long it takes for how big to execute, right? So what we're going to do is that we're going to make it we're going to add a million items to the list, start the timer, call how big, and we're only going to time how big because right now I'm not concerned about like the amount of time it takes to make the list. What I'm concerned about is how long it takes for how big to execute. So we're going to run this, and we're going to see that it takes no time at all to execute. Okay. What if I make a smaller list? That's right. It's not gonna go faster than 0, right? That's gonna be 0 as well. Really big list. How many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1 billion items. That's actually gonna take a bit of time to make. So 100 million items, right? It might take a bit of time to actually add 100 million items to my list, but once it does, it's going to report 0 because returning a variable takes no time whatsoever. See, made the list, we started the timer, we asked how big is the list, right? Because when I'm talking about big O for a certain algorithm, I'm asking about just specifically the, how long does this take to run? Okay. So, what does that mean for a constant time algorithm? Well, essentially that means that it just takes a constant amount of time regardless of the input, right? If you were to graph it, right, and I think, let's go ahead and draw make some terrible drawings here, right? If I were to graph this, right, whoops, okay, suppose this is the input size, which is n, right, and this is the amount of time it takes. Right? The amount of time it takes versus the amount of time it takes versus the size of our input, right? Our constant time algorithm graph is going to look kind of like this. Although, it's going to look something like this. It's going to look like a straight line. It doesn't matter what your input time is, right? If I were to graph out everything, the constant time algorithm, regardless of the input size, it's always going to be, some constant amount of time. It's going to stay the same no matter whether there's 1,000 items that I'm dealing with, 100 items I'm dealing with, or so on. Now, an O of N algorithm, which we're about to go over, it looks like this. It looks like this. Okay? It says that there's this function out there, basically, and it's going to essentially have a linear relationship. Specifically, an O of N algorithm, you'll see, it's a bit more complicated than that. But for right now, the understanding you need to know, and we're just going to simply build on and expand on that understanding until we can get to the mathematical definition so you guys can understand it, is that there's a linear relationship between the amount of items you have and the amount of time you have. So if you have n items, it might take n steps, or it might take 2n, or 5n, or 100n steps. But it's about having that linear relationship. Okay? As the slides put it, it expresses the performance of an algorithm as a function of the numbers of items to be processed. Right? That's what we're saying here. That the number of items you have to process, the number of steps it's going to take that algorithm to complete, is it is indicated by the big O notation.